Hi, Kirsten, how are you?
Hi, I'm good.
Okay, let's wait for Jiang. Actually, we are already 8 o'clock. I sent out a notice for Jiang already. Okay, we'll get started. Okay, before we go into the material, let's actually review our schedule. So last time we worked on chapter 11, the heaps. Today we will be working on chapter 10, set a map, and then next week we will working on chapter 12, tree. So far we are actually on the data collection. It actually is a standard library available in Java. Okay, we only touch this part. This you can consider this about 1/3 of the data structure course. Okay, 1/3. So about 1/3 of data structure. There are another 2/3 data structure course we haven't teach yet. Okay, but what this actually is where we are right now. Okay, we will finish up to the whole data collection, and then user code bronze we cannot finish it before the AP exam, but we don't want to waste your time because everyone need to take the AP exam. So starting from February 28th, we will start it for AP review course. Okay, AP CSA review course. Okay. And then there are a lot of homework there as well. Okay, that's our schedule. And then starting from June, we may continue the user code bronze to finish it up. Okay, at least the whole chapter 1 of the gateway parties, we will finish that, and then some other problems. And then maybe this one is maybe depending on how many people still interested. If less than 3 people, then we will not open the course. And then we will start CC double plus in June as well. Okay. Why CC double plus? Because if you want to go to the gold division for user code, Java is not fast enough. Okay. Java is a good language to teach you object-oriented programming. You know the data structure much better in Java. C is very blurred. Okay. C's language is very freestyle, a lot of things that will bother you. So we use Java as the first language to teach, to give you a better idea of what is object-oriented programming, what is graphic user interface design, what is data structure, what is data collection, what is sorting, these kind of things we teach you in Java. But if you want to get the better performance, C double plus would be better. Okay, there are some problem in code division. If you don't use a C double plus, you just use Java, you can never solve it. You will always time out. Okay. I tried it before. There are some problem. I tried Java and using the same algorithm as C language, but never get it done. Okay. Just get a timeout. And then if you try Python, okay, Python actually some of the bronze level problem already too slow. So Python is not a good language for competitive programming. It is a good language for AI design, but not a good language for user code. Okay, that's language selection. And then how much competition you need? Okay, let's assume that you want to go to college for CS major. What level I think is good enough for doing college and also getting the interview? I would say gold division is good enough. Okay, platinum and the team and the IOI is optional. Okay, you don't need them actually. You don't really need them because if you work on these, you need to spend another 2 years of heavy coding. You may get there, but you will sacrifice your physics, your math, your literature. You will sacrifice a lot of things just want to get it. So if you want to go to MIT, getting the IOI gold medal will help you. Yeah, yes. But you will narrow your research field only down to coding. And that's very dangerous, especially nowadays coding can be replaced by AI a lot. So it really not really that rewarding right now if you just go continue do a lot of coding competition until IOI. It actually doesn't help you. it will help you to go to college like MIT or maybe Princeton, but it has not going to help you in the career of knowing about AI. You don't need that. To be good in AI, you need to be good in coding. Coding is also needed. Computer science is needed. You also need to be good in math, also physics. Okay, physics means the modeling, mathematical modeling. You need to know about double E's signal and system. Okay, you need to know them. Okay, that's my idea, just sharing with you. We'll go back to our material right here. Chapter 10, set and map. Okay. Last time we talked about heap. So what we get started is that we talk about array list. So using array as the list, we talk about linked list, using linked node as a list. So these are all one-dimensional data structure. And then we talk about heap using the array as a tree. Okay, as a tree. So we talk about heap last time. So you do know about some tree. But there's one thing that actually we need to understand that why we study these different set map or array list or linked list. Okay, why we want to study this? Okay, let me ask some person, Kingston. So why we study data structure?
So you know what you need to use and you don't have to like reinvent it.
Hmm?
So you only need to reinvent it when you need to use it.
No, no. You don't need to read it in the. That's actually is for library builders. Library builder will build a library for you. In a way, that's the reason why we want to do this data collection. That's correct. But for programmer, why we need to study data structure? For programmer, why we need to study data structure? For Jiang, do you have idea?
What do you mean?
What's the purpose of studying data structure for programmers?
Because it's like the base of every object-oriented language, I think.
No, data structure may not be object-oriented. It may only
Then,
be a linked list, a linked node. So it's not the purpose of that. Okay. How about Harrison? Why you study data collection, data structures?
Is it so that you know like which algorithms are like more efficient than others?
Yes, everything go back to the big O notation. You want to do n or n square or whatever actually make the program faster. The optimal goal is still make the program more efficient. You may trade off memory with the computer speed. That means you sacrifice some memory, use more memory, but you want to make your program run faster. That's the whole purpose. We study the whole thing, so many chapter, different kind of data structure, everything go down to here. So you need to be sensitive in terms of each data structure's access time, search time, insertion time, deletion time, all those kind of things is you need to be very sensitive. Especially when you go to the competitive programming, you may be bumped by the timeout problem. Then you need to study what kind of data structure we can use instead to make it faster. Okay. So that's the purpose. We want to actually find a better performance program to help you. Now, go back to set a map. So we do study for one-dimensional array. You do searching, it's an order of n times, right? You go heap. You find a data in a heap or find a data in there. Your time maybe is log n, okay, whatever. Now, can we do faster? like order of one or a constant time algorithm? Can we do that for searching?
Yeah.
How can we do it?
So like sets, you use
So how can set be so fast?
they remove duplicates.
Hmm?
Like it only stores the ones that are not inside, like no duplicates.
No. If you have 5 data, if no duplicate, you put into the array, it's still an order of n. That's not a reason. Okay, let me ask Harrison. Harrison, why have you actually in your 3rd grade math, did you memorize a 9x9 multiplication table?
Yeah.
Why do you do that?
So it's like easier to like
Why easier? Why 9x9 multiplication table is easier for multiplication?
because you don't have to like redo the multiplication every single time you want to know the answer.
So what's the theory behind the 9x9 table?
It's big O like n equals to 1 because you only have to go through one case to find the answer.
So memorization actually is the most important part. If you remember it, it will be actually the most efficient one. Okay. That's the whole key. So the faster computation is table lookup. You don't go by the algorithm, you just store the data, the solution is somewhere, you directly copy the answer. The table lookup always be the fastest solution. Okay? 这样 is that okay?
Yeah.
Kingston, is that okay?
Yeah.
Now, the problem is how can we use the idea of table lookup in general? So 9x9 multiplication table is actually for multiplication. You know 224, 224. So 2 by 2, you get 4. That actually remember them. But in general, computer, how can computer actually do this? Okay. Yeah.
You can like hash it.
Yeah. So the key point is the hashing. Okay. Now, before we go into the hashing, the first thing that we want to do is actually let's look at something. So you do have a 0, 1, 2, 3, 4, 5, 6, 7, 8 different string. Let's assume the data is stored A, B, C, D, E, F, G, H. So now if you want to have the index for D, then it will be 3. But if you want to find out this index 3, you need to go through the whole array. So you have 2 ways you can do it. One way is you do linear search. So it's the order of half n algorithm. We say order n algorithm. If this data is sorted, you do binary search. You do binary search, then you end up with a time of order log n. So worst case would be 3. Best case is 1, but it's log n time. When n grow up, it's only log n time. So basically, binary search is faster. So now we want to do hashing. So there is a concept being introduced to hashing. It's called content addressable. Content addressable memory. This is the fastest memory that you can do. Actually, in AI, a lot of things need this content addressable memory. So if you search the internet, okay, there's a CAM, content addressable memory. There are many study in content addressable memory. Okay, so basically, as you look at this one. Oh, no. Well, this is the video. I'm sorry. I don't want video. Let's try something. This one. So usually the memory, you actually use the address to access data. Now you want the data to access the memory. Okay, that's called content addressable memory or associate memory. And this kind of memory is very useful in parallel processing and even AI. Okay, so this is a hardware design. Okay, so that's okay, let's actually stop there. Now, so content addressable is the idea of you use your data A, so I use the search A and directly return me the index, certain index, so 0 being returned. Then I know it right away. If you give me the A, I'll get the data. This kind of association, we call it content addressable memory. So hashing is one way to do content addressable. So let's assume that we do have a memory location right here. Okay, big memory locations. Now we do have an A, and then we use a hash function. Okay, this hash function usually is something very similar to random number generator. So you actually put an A in there, and you give you, for example, give you AFB4. So you go to AFB4, and your A is stored right there. Okay, so basically you use a hash function, put in your content in there, and you give you an address, and your A is right there. Okay, so if you hash and then there's a data, then you know it exists. Okay, so that's when you put a B there, and then you have a hash function to calculate it, and you end up with 24BF. Then you go to B24BF, and then there's a B there. Okay, so basically, by doing this, your time of access is only a function of the calculation of the one hash function. So that actually is the order of 1, is a constant time. Is that okay?
Yeah.
Yeah.
Okay, so this one is a constant time. And this kind of set or this kind of map, we call it hash set. It's a set made of hash table. Okay, now we don't want to go into hash set yet. If we don't do this way, is there another way we can do it? Yeah, there are other way we can do it. We can use tree. We can use tree. So that's assume that actually we have a node. So right here, the first node, and then after the first node, we branch out to 26 different nodes. So it actually is starting from A to Z. And then from A, we continue to spread out to A to Z. Okay, so for example, if B don't have data, we actually do not put data here. C don't have data, we don't put data here. So in this data structure right now, we do have a AA, AG, and G. Okay, that's assume all others doesn't exist. So we have these 3 in the dictionary. Okay, this kind of tree we call it trie. Okay, trie. So if you want to see if AA is in there or not, you actually do searching for the root node, and then go down to here, and then go down to here. Yes, AA is in there, so it's actually the search time is a order of 2. The 2 is the length of the word. It's not log n, it actually is length of word. It's not the total number of the element. It's actually is the length of the word. So it still be a constant time. Is that okay so far?
Yeah.
This type of data structure, we call it trie, and it actually is a tree structure. And it also can be used as a content addressable memory. Okay? Okay, so this type of the memory, we call it, this type of a set, we call it tree set. Okay? So there are tree set, there are hash set. It's different way to implement it. Okay, so here you do see there's a hash table, tree map, hash map. Okay, these are different, these are tree set. So there's a hash set. So set has set made of hash table, set made of tree. Map has a map made of hash table and map made of tree. Okay, so these are different way to implement it. Java all implement them. Okay, is that okay so far?
Yeah.
Yeah.
Okay. So we starting from teaching you the hash table and the trie tree, TRIE trie tree, that actually before we go into the set and map. Okay, now the difference between set and map. Set and map actually is the same thing. Okay, so let's assume that we actually do have a hash table. So we hash A, and then you get 2AF4. So you point into some location, and you do put a over there. So if you do hash K, maybe not in there, so you calculate some numbers. So let's assume it's AF22, but you go to AF22, there's no data there, it's null. Then we actually know that A exists in the set, and then K doesn't exist in the set. So when you do a set that contains using one hash table time, you know it's in there or not. So this is actually, we call it set. Is that okay so far?
Yeah.
So if you add a data, you hash it and store it in there. If you do look at the second A come in, you will hash to the same location. So it won't duplicate because A is actually only have one copy. So this we call it set. Okay, you don't have the data copy. Okay. Now this is set. How about map? Map, let's assume that you do have a and you also store its index, so 0 being stored in there. So you have a string versus integer. So B was stored with 1, C was stored with 2. So this is key versus value pair. So what we would do is actually map is similar to set. You hash the data of A, you got some data of 2FA4, and you point into somewhere, and then over there you store A combined with the value of 0 there. So the only difference between set and map is like set do not have the value, it only had the key. Map had a key and value. Otherwise, the whole data structure is the same. Does that make sense?
Yeah.
Okay. Okay, now, so this is the difference between set and map. Let's go back to Python. Some of you may know Python. So Python's dictionary, you do have a key and value, key and value, key and value. So in a way, Python's dictionary is also a map. Does that make sense?
Yeah.
Okay, so Python's dictionary is also a map. Now, we have enough discussion about set and map in general, okay? So this part will finish our most of the data structure, except for the tree. We will talk about tree next week for searching for the tree structure, okay? Otherwise, we almost finish the whole data collection now. So these are the big idea of the set and map. So this chapter we cover set map and teach you what's a tree set, hash set. Okay, these are two kind of set. A map also has a tree map and hash map. Okay, and then this is contain adjustable memory, reverse array, random permutation. Okay, random permutation, random seeking. This different application for set and map. Okay, so map, we talk about map already. Map is actually with the key and value pair. And the key portion is the same as a set, okay? So you do have a map of key and value, and then key and value is a map of key and value is an interface, okay? Hash map is a concrete class. Map itself is an interface. You do have a key and value, and then the key and value being put into the memory, and then you use the key. Key is the data that you use for hash function, okay? Or you use it for tree search, okay, depending on which one you are using, okay? So you do have a map. Map is actually a interface, okay? You do have hash table, hash map, tree map. This is used made of tree. This is measured hash table. There's another one called hash linked hash map, okay? It's different from hash map. Now, these two, you have to be careful about these two. These two are similar but not the same. Now, let's assume that you actually do this. Let's assume that you do hashing. So you do have a memory, and then you use a hash function, you hash A, and then you go to somewhere, you store A in there. But somehow, you keep adding more word into there, okay? So B go in, C go in, whatever. Now, maybe there is a word, let's assume that you actually have a word called happy. And this happy word hashed to the same location as A. Okay. Then something bad happened because you have collision. If the hash function do not spread out the data to different location, that actually happens sometimes, then you have collision. When you have collision, you have two ways to make it. Number one is you use a linked list to connect the data. So A right here, and then happy right here. So there's an order of M. M is the number of the element in the hash to the same location. So that's called linked hash map. Okay, that's one way you can handle it. Is that you actually store them in a linked list. Second way you can do it is that you hash A to here, and then next one happy come in. So happy come in, you do see there's some data occupying it already. So you use a hash function number 2 to hash happy. So you have to hash to somewhere else. And nobody there, so you are happy over there. Okay, maybe you go into hit to the B again, so you will use the hash function number 3 to do rehashing. So rehashing is one way to avoid but there's no guarantee that it will solve the problem. So sometimes the hashing may hash several times, 1,000 times maybe. So when you design the hash map, it's careful, need to be able to bound the upper bound for the number of times that you hash. So a lot of time people just use the link hash map. Does that make sense?
Yeah.
Okay. Anyway, these are different data structure we want to cover. Okay, so that's the map of the key and value. A map of key and value is the same. The usage is the same as Python dictionary. Okay, almost the same. They do have a clear function, contain key function, contain value function, empty set function, get key is empty, key set, put function, put all function, remove function, size function, value function. Okay, these are simple function. We don't waste time. Okay, let's go. In the old days, there's an abstract class called dictionary as well, but it's already a legacy class. It's out of date. Nobody uses it anymore. Okay. And then concrete map classes, there are tree map, hash map, link hash map. These three are all map. Okay. Map is a interface. Map do not have constructor. So when you want to construct, created a concrete class, you need to use a tree map, hash map, or link hash map. Okay, there's a abstract class called abstract map, but that's actually transparent. Okay, no need to do that. Tree map is also sorted map. Okay, when your data in the map also be sorted, then you can actually use a sort map. Okay, so what is a sort map? Let's assume that you use a tree map. And tree map using the trie structure. So your trie structure do have A to G, A to G. So if you do depth first searching, then the data is sorted. Is that okay?
Yeah.
Okay. So tree map is also a sorted map, and it do also give you the sorted. So if you keep putting the key into a tree map, in a way, the data also sorted. Okay. So you do have the first key, last key, comparator, okay, whatever. There are several functions that can use for a sorted map, okay? Okay, so these are the structure of the relationship of the concrete class and the interfaces. Now, efficiency. Efficiency, your access time, hash map order 1, in hash map order 1, hash table order 1. Tree map we say is order log n because it's actually the length of your letters. Okay. So tree map is slower. But tree map had a good advantage of being sorted map. Others are normal map, no sorted. So usually this one you have to use it whether you like it to be sorted or not. So sorted give you the order of the data, but normal set or normal map do not have the order. So whether order is important or not, you have to decide, okay? And then implementation here is say it's a bucket. Okay, bucket means that you have an array of data. So you hash to the same location. That's so this is A. So whoever's hashed to here, you will store in the bucket. And this bucket can be a linked list. Okay, so this bucket just saying that everybody hashed to the same location will be put into a bucket. Is that okay? Okay.
Yeah.
And then tree using red black tree. Okay, then red black tree will be covered in data structure. It's not important here. One thing is that red black tree, if you do interview, they'll test you. Okay, usually they'll test you the idea of red black tree. Okay. So we have enough idea. So this is hash map. So there's a Jiang Smith, Lisa Smith, Sam Doe, Sandra Doe, Ted Baker, and each one of them hash to different location. Different location, this one means that you hash to the some edges. Key being hashed to some edges. So inside here, this has a hash function to do conversion right here. So you hash to a location. So if somebody hash to the same 001 bucket, they'll give you the key and the value. Name and the phone number, name and the phone number, name and the phone number. Okay. So if you do not have the value, then this is a set. If you have the value, that is a map. Okay. And then this one actually two of the data hashed to the same location. So this one and this one has collision. So you use a bucket. So it's a linked list to store two data there. Okay. Any questions so far?
No.
Okay. Content adjustable memory. Content adjustable memory data. Normally you have the address input. You get the data out. This is a normal RAM. CAM is you use the data in and then you give them the address. So this is the difference between content adjustable memory. Right side is CAM. Left side is RAM. Random access memory. Random access memory means that you give them an address, they'll give you the data. Content adjustable memory is that you give them the data, they'll give you the address. Okay. So content adjustable memory is a hash function. Okay, whatever. We don't want to overemphasize this part. Okay, before we go to the hash table, we don't go into the hash table and hash function yet. Okay, let's actually try one thing. Okay, let's assume that we do have an array right here. And I want to swap A and B. I just want to swap A and B, no matter where A and B is. I want to swap A and B, but I do not know where A and B is. Okay, I do not know where the A and B is. So how can I do it? I want to swap A and B, okay? So you can do one thing to build a reverse array. So array is that you do have an index of 0, 1, 2, 3, 4, 5, okay? In normal situation, you use a hash map, okay? Because only sick data, there's not very possible to have a collision. Okay, and you do for integer I equals 0, I less than s the length, I increase, okay? And then m dot put what? You put your string into there, so it actually is s I and I into there. So this one build a map of contents versus index. So your key now is your string. Your value right now is your index. So you want to swap between A and B, okay? So let's do this. So after you swap, you also print it one more time. Then you can swap the content, no matter where the AB is. Is that okay? Now let's change the location. Let's change this one to A. Change this one to B. Any questions so far?
No.
So
No.
map can be used as a reverse array. okay, as a reverse array. Array is using index to find data. Now you use data to find the index. Okay, Kirsten, when do we need to use a reverse array?
Um, I don't know.
You don't know. How about Jiang? When do we may need to use a reverse array?
I don't know.
You don't know?
Yeah.
It is used in encoder decoder. Okay, encoder decoder. So you can actually decode directly using the encoder's reverse array to do the decoder. Okay, so there are some data actually, if you actually do some sort of transform from one index to the other, when you try to come back, there's a certain usable problem to do that, and then the reverse array will help you. Okay, and then reverse, we will see that when we see the problem. But that would be a very important part. Or sometimes your key set in the encoder is randomized. Okay, it's randomized. Then you may want to do that. By the way, there's one question. I have A to G. I want to put them into 26 numbers randomly. How can I do that to be efficient? I have A to G. I put into the array of 26 entries, but A to G is scrambled. No repeat. And everyone should have at least one entry. How can I do that? Hello? Anybody know?
Wait, can you repeat the question?
My question is, I have A to G. I want to put them into an array of 26 entries. How can I put into there in random order?
I have a way, but I'm not sure if it's like the most efficient.
Just say,
You use like math.random to generate between 1 and 26, and then you mark that number in like an array, and if it's
that
equal
doesn't
to
work. That doesn't work. That's not efficient because you randomize to here, and next time you may randomize to the same location. You waste this time. So when you have 25 data already, the last one is very difficult to get in.
What if you just you put it in normally and then you just swap them? Like you swap them
Swap
like
them, okay. Swapping them, okay. Yeah. You put them into the regular order and swap them, that's okay. Yes. But is there any other way?
Well, can it be that you do like a random number, but the random number of like the remaining numbers?
Yeah, how can you do that?
You have like an array of all the numbers. Then once you pick it, you remove it, so you won't pick it again.
Not array list. You use an array list of 0 to 25. Okay. And then that's as soon A comes. A actually pick 17. So you put A in 17 and you remove it. So there's no more 17. Then you continue to randomize. That's as soon as 13. So B being put into 13. So keep doing that. This one will be shrinking until there's only one data. So the last one will automatically go to the last location. Is that okay?
Yeah.
Okay. This is just another way to handle the index. So why here we talk about index so much? Reverse index or selecting randomized index. You actually, a lot of time you do searching, you are processing only the index, okay? Index and data, there's a mapping, and the mapping is not hard to do. You can also use the index using the array to map it, or you can use a map to do reverse mapping it, okay? Okay, that's just an idea. Okay, now we want to go into the hashing function. We go into hash table. So hash table is the key right here. If you don't use the try or tree, hash table is a key right here for this map and set to be possible. Okay, so hash table usually is implemented in C C++ because C++ and C has a faster ages calculating capability. Okay, and it's actually more low-level language and directly access the data. So hash table is to find a key value pair, okay, whatever. And then they will be using different collision way, and then maybe using bucket or chaining, okay, for the collision avoidance. So this is hash table we talk about. So this one without a value, this one is a set. And sometimes set is also called hash table, okay. And it's faster access time. It's an order of one access time. Okay. And in C++, this is called an ordered map. Okay. And C++ also has an ordered map, sorted map, and ordered map. Okay. So C's library has more different variety to use. Okay, so hash table is you use a virtual address that is sometimes your content, sometimes it's a string, sometimes it's integer. That's your key space, and use a hash function to map to physical storage. So usually this physical storage is smaller. Virtual space is bigger. So this one may be a address. So for example, you buy a computer or memory, maybe 16 giga. You buy 16 giga memory, but your virtual memory, it maybe is 1 trillion. And you are hash mapping to your OS is mapping to from your 1 terabyte memory address into a 16 giga memory that's on board in US RAM. Okay, in US RAM. If they miss, then they will try to find a memory or hard disk to store it. Then we call it page swap. Okay, page swap. You will swap a page of the data from hard disk to the physical address, physical memory. So hash table is not only used for software, it's also used for hardware. Okay, when you do computer architecture, you also use for hardware. So usually the hash function is using the modular function. Okay, so you use a k and you modular. So this number can be very huge, but the real storage is only 10 data. So you actually hash the data to a certain location. Okay, and if this one overflow, then you would have a bucket, okay, to keep more data into the same hash location. So then there is something called loading factor. Loading factor is your total data divided by your physical location. So for example, you have 5 data, and then you have totally 9 edges. So your loading factor will be 0.5. You will load the data of 0.5. But sometimes you may load the 20 data into 10 data location. Then your loading factor is 2. That actually is overflow. So on the average, each entry had 2 data. Okay. So hash table can be overloaded sometime. So hash function usually try to hash the key evenly distributed so among the cells. So usually this one is a random number generator. Okay. Try to be fair, but it can never be always fair. Okay, so there will be some collision. So there are different way of doing the hash function. Okay, right here you have a string character 1, 2, 3, 4, 5 to k, and then you do summation of the numbers and then mod the table size. Okay, this is one way to do it. Okay, there are several ways to do a hash function. We don't go into the detail of each hash function's design. Okay. Then separate chaining is talking about the chaining part, the buckets, using bucket to put more data into there. And usually the implementation can be an array list, can be a vector, or can be a linked list. Okay. And this one is loading factor. Okay, loading factor. So usually the table size tend to be using the prime number, because prime number when you do loading, it actually when you use the mod, because your load your hash function usually is mod using mod table size. So this one usually is a prime number. Okay. So for example, 2 to the power n minus 1 usually use that. Those kind of number. Okay, there are several different ways to do probing. So they are linear probing. Linear probing is that you actually hash to 2, and if there is an overflow, there's a collision, you probe the next edges. Okay, if you keep probing the next edges, this one we call it linear probing. And some other people maybe actually probe by jump by 2. That's also possible. Okay, you can also do jump by 2, jump by 4. Up to you. All of these we call it linear probing. Okay, it is also possible to do quadratic probing. So the first time you go by 1, second one you go by square. 2 square is actually go by 4. Third one you go by 9, something like that. Okay, that's called quadratic probing. These are different ways of doing collision rehashing. Okay, whatever. These are different idea of the hashing. Okay, we don't go into the comparison of these different kind of probing. We just give you the idea of what it may happen when the probing has some problem. Our purpose is to teach you the data structure. We don't teach you this hashing function yet, okay? That's another story. So Java's memory allocation, when you do new, actually Java also use a hash function to find the memory location for you, okay? So that's why Java has a hash code function. Okay, let's have a break for 5 minutes. We'll come back to work on this program of occurrence of word, okay, using the map, okay? Let's have a 5 minutes break, come back on 9:07, okay? Hello. Hello.
Yeah.
Okay, we are back. So now we are going to look into the application for map, okay? First one, let's look at this decoder problem. Decoder problem, okay? Okay, sometimes we want to do encoder, but our encoder, we don't want to use Kaiser's encoder jump by 3 or a fixed key encoder. We may want to use a random encoder. Okay, we may want to create a random encoder. So let's assume that we want to create a random mapping or using an array. Okay, using an array to do mapping. Okay, so let's do this. Let's do this. Okay, so you go into different characters. You have A to G. Okay. Okay, you put that into the alphabet, right? And then while alphabet, the size greater than 0, we do something, okay? Okay, so each time you get the data and put into the encoder. And this one is let's actually put it into two line, okay? So let's make it more readable. It's actually too long. So you randomly generate an index. Okay, and then you keep removing the index locations data and put it into the encoder with P++. Okay. Okay, so this array is randomized with A to Z. Each one has a data. Is that okay so far?
Yeah.
But now if you want to do decoder, this one, you want to decoder right here, you actually okay. If you want to do the decoder, right now you have this encoder now. And you want to do decoder, you actually need to do okay. And then you build a decoder. Let's call this one decoder. So now you have an encoder and a decoder, and you want to pass the data into here to test. Okay, so let's actually put a source data. That's so this is the source data you come in. Then we will put them into the encoder. So we do encode the data. Okay, and then for the character with it, which character should be added is a string of right now you have an encoder. So your encoder right here give you the different data, right? So it actually is A to Z. Your encoder is right here. So they are totally 26 data. It actually is 0 to 25. So A would get this call. Okay, so you have the source that character at I minus A. This is the index number, and then use the encoder. Okay, encoder itself is a string, so this double quote plus is not necessary. So you put that into the encoded message, okay? So this is a KKBA CBCAC, whatever. This one will be encoded. So let's look at the encoded data. So this one is the mapped array, okay? So it being mapped to here. So I think K mapped to this letter T, okay? So K, okay, B mapped to M, okay? Is that okay so far?
Yeah.
Now we want to recover this message from, so basically you do encoder, you source data, doing encoding, going into the communication channel, coming back, you do decoder, and you do recover the signal. Okay, that's actually what we are doing. So now we use the map to do decoder. So map already built up the decoder. Okay, now let's do it. Okay. Encoder is a array, I'm sorry. It is encoded, I'm sorry. It's encoded string, not encoder. Encoded string. Okay. What's wrong? Cannot be converted to string. Encoded the substring. So encoder of the character minus A, that would be a string. Or encoded is actually a string. So how come it cannot be converted into a string? Something wrong. Okay, let me check. So encoded is a string. Encoded the substring. Something wrong. How come this cannot be true? Let me check, okay? Decoder is a encoder. I is a string, so let's put the string in there. Integer cannot be converted to a string. Integer incompatible. Integer cannot be converted to a string. What's wrong? Decoder is a map. String integer, map integer. So you actually put these difference in there. So this one is a integer then. Oh, I see. So this one you get an integer. Then you get that integer, you need to get it from the integer I. So this one is actually you need to A plus this number, and then this whole thing plus with a string. Okay, this one actually you get a number. Okay, this number is the index number, the index number of your encoder. Your encoder's index number, for example, you have 0, 1, 2, 3, 4, 5 to something. So that's actually is 10. 10 means original is K. So you see a T, you get this 10 back, you plus it's A, you recover this later from T to K. Okay. But this one actually need to add it's 0 to 25 domain. You need to add the A character and then convert it back to string. Okay. So that's that. And then let's do recover the signal. Okay. Oh, this one become numbers. It's wrong. Let's see. It's going. You need to convert it to char. Because it is a process, it become an integer. You have to convert it to char. Sorry. Okay. Come back to the right data. Okay. So let's see. Let's actually one more time. So your originally you build a alphabet. Okay. So this alphabet is a array list of A to Z. Okay, in order of A, B, C, D, E, F, G to D. Right. Then you scramble them into a encoder. So this is scrambled. So you do 0, 1 up to 25. So 0 means A will be mapped to, let's assume this is G. A will be mapped to G. So this is a random mapper, random encoder. Okay, so we print out a random encoder. Then this random encoder, we feed them into a codebook dictionary. So you create a relationship of the content with the index. So that give you like Z, you go back to 0. So the original data is A, this is called decoder. Okay. So you build an encoder and decoder. Then your data sent from the source side send to the encoder, and then go into channel, communication, maybe Wi-Fi, maybe something else. And you come back with the decoder. And then you get to recover the signal. Is okay so far?
Yeah.
Yeah.
This is we call this kind of simulation as end-to-end simulation. So end-to-end simulation in communication channel is very openly used. Okay, right here I just give you a simple example. It can be a JPEG, can be a more complicated data to see if it recovered. You can recover the whole thing or not. If you cannot recover the whole thing, then we call it a lossy channel. If you can recover the whole thing, then we call it a lossless channel. Okay. Anyway, this is one application for map. Okay. Let's look at another application for map. Commonly see application for map. Let's look at the counting of the words. Let's use the okay, let's use the Declaration of Independence. We used that before, but this time we are going to use mapped for it. Okay, this one, no. I just want to get the text file. Okay, let's copy. Up to here, the honor. Okay, copy. Now let's go to this chapter 10. By the way, when you do competition, the test data is also your own responsibility. Okay, nobody care about your data. You have to handle your input test data as well. Okay, so this one is a Declaration of Independence. So map can be used for the mapping, encoder, decoder. There's another good application is counting the occurrence of words. Okay, and also there's three applications we talk about today. Another one is a reversal array, decoder, encoder application, and counting of occurrence. Okay. I'm sorry, I don't want to do this. I want to open it with Notepad++. Okay, so I store this in Congress, July 4th, 1766. Okay, whatever this one is. Does it say? Okay, so now we are going to do text processing. So this one, let's call it count words. So because we want to count words, so we don't want to actually, we will get rid of the non-letters. Numbers also not going to be used, okay? No, this is not system type, sorry. Okay. Okay, so we open the file. Now we want to read it line by line. Okay. So let's do it. Okay, so we read in the line and then we actually print it right away, okay? And that's it. So far, we just want to do this, making sure that the data being read in correctly. Okay, so that actually do read in a lot of words. Now, before we do processing, we just care about the words, so we don't care about the uppercase, lowercase. So this one, we directly change it to lowercase. Because we are going to just calculate the number of words in lowercase. Okay, so we get different. We actually convert it to lowercase. Now we got a line. Now this line, right now we want to get rid of all of the characters, non-character words. So let's do line 2 equals empty string. So for integer I equals 0, I less than line length, I increase. I'm sorry. So this character may be used several times. So let's do char. If not, then it's a number or if a digit. We don't want to connect them together, so we put an empty string there. Okay, so this one converted to line 2. Now let's print out the line 2. Okay, so this line 2 is everything only letters and words and in lowercase. There's no more uppercase. Okay. So there are some letters such as stay, S and stay. Then right now we don't go into the tokenization problem, so we consider these two words are separate different words. Okay. Refused with D or without D, we consider them are separate different words. Is that okay so far?
Yeah.
Okay. Now this one we are going to put the words into a whole list of data. Okay, so let's do this. Okay, so this line 2, we don't want to print it there. Now this one, we would actually find word by words. So we do string tokens. Using space to do split, okay? Tokens is an array, okay? But now we need to trim tokens to get rid of the empty strings, okay? This one may not be good. Let's actually do this. Using not equal E0, okay? Don't use the equal string. Use using equal empty string. So let's do up to here. So this one only the after the trimming, some of the word may be trimmed to empty string, and those we won't put into the character, won't put into the words. Okay, so far we get a listing of all of the words possible. Okay, so these are all the words one by one. Now we actually get all the word up to here. Okay, so first one read in line by line and split, and then trim everyone, and then actually get words. Okay, so now we get words in the tokens. Now we want to put into the map now, so we want to count the occurrence. So map. Okay. Okay, if the word not in the map yet, then our map will put with zero occurrence. Never happened before. Okay, so now after this point, everybody, you may have a word that already there, okay, or never happened before. So the word may be A, B, okay. It may actually happen for 2 times. Okay, now you need to update this one to from 2 to 3. So right here, you set the non-existing word to 0, then it will increase from 0 to 1. So it's actually okay. So then we do this. We do m.set. Okay. So you every single one you will increase by 1. Something wrong. Let's see what's wrong. Undeclared method set. Or put. Not set. Put. Sorry. Okay. So this one, you update the occurrence of each word. So you go get every word and put it into the map. Okay, now, next one, you want to list down all of the words and contents. So let's do this for each string k from m dot key set. So key set get everything from the key, okay, and then you do system.out.println. You print f percentage s percentage d percentage n m dot get. Actually, you should put k and then m dot get k. Okay, then you will have the word and the number of occurrence word, a number of occurrence. Is that okay so far?
Yeah.
And if you continue, you can do solid, okay? You can continue to sort which occurrence have more, okay? So we don't do that right here, okay? We already 9:44. Any questions so far? Any questions so far?
No.
Okay, to summarize, today we cover the set and map. We're starting from the so-called hash function and the tree. We talk about try, but we did not give you the example of try, okay? But we emphasize on the hash table. And then from there, we talk about the hashing and then the relationship of hashing function with set and map, okay? Set is a collection of key without value. Map is a key with value, and both are hashing into a bucket, okay? And then next one is that we look into the hashing functions, possible collision problems, okay? And then we go into the application for map, including the reverse of string, reverse mapping using encoder, decoder, and counting of the occurrence. Okay, 3 major applications for maps. Okay, and that's it for today. Any questions so far?
No.
So next week we'll go into the tree structure and then we'll talk about the tree and graph and talking about the adjacent list and the adjacent maps, and then do depth first searching and depth first breadth first searching for graph. Okay, that's a simple part. And then we will have everything needed for the Euclid bronze. Then you need to work on the problem more. And then for the problem solving part, if we have time, we'll return in June. Okay. At the same time, we may also kick off the CC plus in summer. So making sure we go into the more advanced programming. Okay. Any questions so far?
No.
No? Okay. No, that's it for today. Okay. Good night and bye-bye.
Bye.
Yeah.
Thank you.
Bye-bye.